Welcome you all to this Unitrain System DC machine environment. Today we are going to see how DC machine works in Unitrain System from Lucas Nella. Stay tuned and follow the instructions to learn the Labsoft software and the laboratory setup faster. Let's begin. Welcome you all to the electrical machine lab. Here we have used Unitrain System, which is coming from Lucas Nella. This is a DC machine which is being controlled. We will be looking into the details how this can be done. We also have a virtual instrument. This is the electrical machine virtual instrument which we are using to control the DC motor over the way. This is the DC motor which we are talking about. Here we do have a stator, the fixed part which doesn't rotate. This is the stator part, and we do have a rotor. This is the rotor, the rotating part of the DC machine. And here we do have different supplies. As you can see that this is the first supply, 15 and 0 volt, which is being connected to the stator winding. So this is the stator, and that's the stator winding over there. And these are the winding coil, representation of the winding coil. And we do have got to give an exciting voltage to the stator coil, and that is the 15 volt which we are providing over here. In DC motor, other than the stator coil, we also need to give supply to the rotor so that the electromagnetic waves can be generated. So this is the rotor voltage which is being supplied by this variable voltage V1, V2 and V3 and COM. These are a part of the variable voltage. Here we are providing the variable voltage through those points through to this rotor. So how do we control the variable voltage? Here in the virtual instrument, here we do have DC motor supply voltage variable instrument. We have got to turn on that, and here we would be able to control the voltage which can control the speed of the rotor over here. When we reduce the voltage over here from 20 by clicking on this arrow, we will be able to control the speed of the motor. This is called the stroboscope. So stroboscope is having a function similar to a tachometer, wherein which we would be able to identify the speed of the motor. So that is being done with this stroboscope. Basically, what is this stroboscope? Stroboscope is just an LED. You can see over here, this LED is blinking. It is at a particular frequency that is blinking. We have set 100 Hertz as an LED frequency. This frequency is in line with the speed of the motor, and we would be having an illusion at one particular place in which the speed remains fixed or constant. So that is where we would be counting the speed, and that is what we are going to note it down. Okay, here we have put the stroboscope near to the rotating motor. As you can see, an illusion that the motor is not rotating. So the stroboscope is running at a particular frequency, and that frequency, when it is aligned with the speed of the motor, we have this illusion as if the motor is standstill. Coming to the stroboscope, this is the stroboscope virtual instrument, wherein which I have initially connected to 100 Hertz frequency, and which was reduced gradually to 99.7, wherein which we have identified that the illusion comes in wherein which the motor seems to be fixed without any movement. This is the speed at which the motor is running now, and that is what which we are going to note. So this is the relation between the frequency and the speed of the motor. Now let us start to see how we would build this electrical machine from the scratch. So we do have the stator. This is the stator part of the electrical DC motor machine. This is the rotor. This is what it is rotating. and we would be inserting into the shaft of the stator while we connect it. These are the two devices which we use it, the basic device wherein which the power supply is being connected to, and all the input outputs are taken out from this. That is the basic unit. And the second unit is wherein which we put on the PCB which has got the stator part of the DC motor. So this has got to be inserted. So, and we do also have two power supply. Basically it is called 2A and 2D. 2A is meant for the fixed power supply, as you can see over here, plus 15 volt, 5 volt, 0 volt and minus 15 volt. So that is the fixed power supply, and this is the variable power supply, V1, V2, V3 and common. Why do we have a fixed power supply and variable power supply? It is because for the DC motor, we need an exciter voltage which is given to the stator, and that is given as a fixed voltage. While the rotor, if it needs to be rotating at a different speed, we need to provide it with variable voltage. So we do have two different voltages, and for that we do have two different power supply. Basically there is a difference in this. You can see, give a closer look. One of the power supply has got 8 pins and another power supply has got 6 pins. So you have got to see it over here, which is that slot wherein which that 8 pins goes. This is the 8 pin slot, and this is the 6 pin slot. It has got to be inserted in the right way. So let's insert that now. So the first one is inserted. You have got to be very careful while inserting this, or else the pin can break. So the slot is available there. So it has got to be put in the right slot. Now the 8 pin power supply and the 6 pin power supply are connected. Now let us connect this power supply based device and the second device wherein which we will be connecting our motor. So that is being connected now. Now it is interconnected. All the electrical connections are in. Let us now start by inserting the stator. So this is the stator, as I've indicated. Stator, as we know that it would be fixed. Here you can see that is the electromagnet. This is the electrical coil which makes this electromagnet when supply is being provided. I repeat, these are the coils which energizes this iron piece to make it magnetize, in turn making it an electromagnet. And these coils has got, and these coils is not connected with each other. So this is what it represents. These are its terminals, and we are going to use this jumper to make it in series. You can see that this is the first coil which represents this, and this is the second coil which represents this. So with this jumper we are going to connect it in series. Now these two coils are connected in series, and the fixed voltage would be provided at these two pins such that our coil will get energized at a fixed voltage. Now let us insert this stator into the device. So it is through this slot we have to insert. You can see how it will be inserted. So you have got to push in such that this button comes at the top, such that it is fixed now. Right. So now we have inserted the stator. Let us now insert the rotor. So this is the rotor. This shaft has got to be inserted into the bearing. So that is the bearing over there. So it has got to be inserted into the bearing, and this knob has got to be put in the 0 degree for the right alignment. Let us now insert into the 0 degree for the right alignment, and we have got to push it into the hole. The shaft has got to go in. Yes. Now it is well inserted. The shaft is well within inside the bearing. Right. Now the rotor is connected along with the stator, with an air gap is already there, and we are now going to connect the wires. So as I've indicated to you, the stator winding has got a fixed voltage. We are giving 15 voltage. So this is red indicates a positive. We would be connecting it to the plus 15 volt, and we would be connecting it to one of the end of the coil here. So we have connected it to one of the coil terminal, 15 volt, positive voltage. Now blue represents negative voltage. We are going to connect it to ground, and that would go to the next terminal. Right. Now we have connected the stator winding to the 15 voltage and 0 volt. Next, our connection is the rotor. So for the rotor, we would be taking it from V2, because rotor we need to change the speed. So it is a variable voltage. We would be connecting it through a small resistor. It is not always required to provide a resistor, but it should be okay. The resistor, when we normally see that, you can see when you have a closer look, it is 6.8 ohm. Normally the resistors whatever we connect to a motor would be very, very low, because if we increase the resistor value, the rotor won't be able to run. So this would be connected to the red terminal, A1 coil. So what we have done here, we have taken the variable voltage, connected through a small resistor, and connected to the A1 terminal of the rotor. Now the second one, the V2, we would be connecting it to A2 terminal. Now the rotor is also connected to a variable voltage. How do you vary the voltage? We would be doing that from the simulator. Right. So before going into the simulator, we do have one more thing. So this is the stroboscope. As I have indicated to you before, stroboscope is just an LED which is controlled by its frequency. So it being basically an output, we would be connecting to the analog output. So that is also connected. The hardware connection is done, except that we do have the USB cable which need to be connected to the device and to the computer, such that our machine can be controlled virtually. So let us now connect the USB device. So USB device is connected to the computer and also to the equipment. Now coming to the software part. This is the software Labsoft, which we can install it from the CD which comes with this device. Over here, this is the box in which you will be finding the CD. So you have got to install that, and you will get the Labsoft X software. So double click on that, click on OK, and you will be able to see that an animated pictorial view of the experiment is available there. So it also indicates to you how you have got to wire it. Before turning on, clicking on this virtual instrument, we have got to ensure that our instrument, our equipment is turned on. There is a switch over here which we have got to turn it on. We can see an orange is being glowing here, green glowing. Both must be green, such that it indicates that instrument, yes, the instrument is connected. Now USB is already there. Let us now click on the DC motor supply virtual instrument. Click on this DC motor supply virtual instrument, double click. You can see that the virtual instrument has come in place. This is the Stroboscope virtual instrument. Double click, you can see that Stroboscope is also in place. Right, so we are all set to start our experiment. So to start with, we have got to set a DC voltage to 20 volt. That's what the normal voltage is, and then we will be gradually reducing the voltage. When we reduce the voltage, we would be able to see that the motor runs at a lower speed. That is what is variable voltage. So here the voltage is directly connected to the speed of the motor. When you reduce the voltage, the speed of the motor also comes down. So this is that virtual instrument wherein which we would be setting the voltage level. To start with, we would be setting it to 20 volt. Let us fix that 20 volt now. Yes, 20 volt is fixed. And this is the stroboscope wherein which we would be starting with the 100 hertz. This is now 1 hertz now. We will increase that to 100 hertz. Yes. So it's 100 hertz now. You can see the relation between the frequency and the speed over here in the stroboscope. I have set here 100 hertz and the relative speed is 6000 rpm. In our test procedure, we would be reducing this frequency level from 100 to lower level, and we would be continuously monitoring with a stroboscope by putting it closer to the rotating rotor and to visualize the illusion of the rotor being stationary. When we visualize the rotor to be stationary, we can note down the speed at which the rotor is rotating. That would be marked. So that is the relative speed with respect to the frequency. Now we are going to turn on the DC motor supply in the virtual instrument, and we would be seeing the reflection over here in the motor. When we turn on here, we would be able to see that motor starts rotating at a particular speed. And this speed can be controlled by reducing this voltage. When you reduce the voltage, the speed also comes down. Similarly, stroboscope, when I press this power button on, you would be able to see the LED turned on and running at a particular frequency. And here I have set 100 hertz as a frequency and 20 voltage as the DC voltage, which would be supplied to the motor. Now let us turn on the motor and also the stroboscope. To turn on the motor, you have got to click on this power button over here. Let me click on that, and you can see the reflection over there, how the motor rotates. Clicked. You can see the motor is rotating now at a very high speed. We can still increase the voltage to around 24 volt. That is the maximum voltage which we will be able to give, so that it will be running at a high speed. Now still the motor is rotating at high speed, and the frequency is to be controlled now with the stroboscope. I will turn on the power button over here. You can see that the LED has been turned on, but it is not just on, it is still blinking at a particular frequency. What is that frequency? It is at 100 hertz at which this LED is blinking. Now, how the experiment goes? We have got to put the stroboscope very close to the armature rotation, and here you can see that we still feel the armature is rotating. We have got to now reduce the frequency at a level wherein which we would have an illusion that the armature is stable and not rotating. Let us now reduce the frequency. You can see that it's almost fixed now. So you see that Lucas Snella symbol is also visible. So you can note down almost to the place wherein which it is fixed. Yes, it's almost fixed. Now the frequency is 99.4 and the speed is 5964. That is what which we have to note down. So we would be noting down here. You can see that is the table wherein which we have got to note down RPM for 20 volt, 18, 16, 14, 12, 10, 8, 6, 4, 2 and 0. That is the voltage level which we have got to enable over here and identify what is the particular speed at which it is running for that particular voltage. And in our experiment, we have got to make a plot of this voltage versus RPM. So that is the experiment over here. So the voltage which we have given presently is 20 volt and the RPM at which the motor is running now is 5964. That is what which has been noted. So let us mark it over here, 5964. So the first value is marked. Similarly, you can note down all the values for the different voltages. Let us now show the second one. Let us reduce the voltage, DC voltage to 18 volt. So let us reduce it over here. There it is. When I reduce the voltage, the speed of the rotor also has reduced. Now I have got to again put my stroboscope. You can see now that the rotor armature seems to be rotating. I will reduce the frequency now, such that at a particular point it would seem as fixed. Yes. So we would mark this 95.3. The frequency in which the speed is 5718. Okay. Similarly, we can reduce the voltage and we would be able to mark the speed. Let us now mark all those. Now we have noted all the values starting from 20 volt, 18 volt, 16, 14, 12 and 10. Now when we further reduce this voltage, now you can see here the voltage is 10 and the speed has reduced to 4194. When you further reduce this voltage, you would be able to see that the motor stops. Let us watch the motor stopping when I reduce the voltage. Now it is 9.7, 9.6, 9.5, 9.4, 9.3, 9.2. The motor has come to a standstill. So now the speed of motor will be 0. So that will be 0 because this motor is a 24 volt motor and it can run well below that voltage to around 10 volt. But when you come below that 10 volt, the motor won't get the sufficient voltage, the thrust to rotate, and it comes to a standstill. Now in our experiment, we have put to draw a graph with x-axis as the voltage and y-axis as the RPM. Draw the graph how the system performs with the voltage. That is what which we are trying to understand in this experiment. So that's the voltage which we have noted down. We can plot the graph now. We have put over here the chart which need to be pressed. We will be getting the chart. You can see from 0 to 8 volt it remains 0. That is, our motor is not rotating, and from there it has increased, then it becomes, it is almost a linear one. So this is almost a linear voltage. You can see over that what indicates that the speed of the motor is directly proportional to the voltage which is being supplied. Hope all of you have understood this experiment. All the best for your learning process. Thank you. That's the end of DC machine environment in Unitrain Systems. Hope all of you have enjoyed watching this video. Let's meet again in my next tutorial. Thank you.